Hi, welcome to our how-to video series on Centerprise Data Integrator. In this video, we will learn how to use the Denormalize transformation in a data flow. The Denormalize transformation is a dataset transformation that allows you to create many-to-one mappings in a data flow. Denormalizing, also known as pivoting, enables you to combine multiple records into a single record. Let's see how it works in Centerprise. Here we have some sample data that contains tax information, which I have retrieved using an Excel file source. I have sorted this data using the sort transformation, and if we look at it, you can see that there are two columns, SSN and tax amount. And there are four different types of tax records against each SSN. For instance, if you look at this data, you can see that there are four different tax amounts grouped together by the social security number. Now let's say I want to denormalize this dataset, as in reduce the number of rows and return the four different tax amounts against each SSN in separate columns instead of a separate row, so that there will be four different columns for city, county, state and federal instead of four records for each SSN. For this, drag the Denormalize transformation object from the transformation section in the toolbox and drop it onto the designer. If you look at this object, there are different nodes for output, pivot and keys, and two input groups by default. You can create more input groups depending on the number of columns you want to create in the new dataset. Let's go ahead and configure the properties of Denormalize. On the first screen, you need to create fields for the new dataset. In this case, I need one field for the social security number and four separate fields for four text values against each SSN. Let's name the other fields as city, county, state, and federal. Set the data type as real and click Next. This brings us to the Denormalize transformation properties screen. Here you have two options to denormalize. You can either create groups based on the sequence of records, or you can create groups based on values in the driver fields table. The first option, that is, create groups based on the sequence, will distribute the values in different rows into different columns in a sequential manner. As in, the value in the first record will return in the first column, the value in the second row will return in the second column, and so on. Let's select this option for now. We'll discuss the second option later in this video. Now specify the number of groups. This number should be equal to the number of rows you are going to denormalize. In this case, let's set it as 4. Now you have to select the Denormalize key. This key will be the unique identifier for records and will be used to group them by. In this example, the social security number will serve as the key field. And then we have the sorting option. So for instance, if your input data is unsorted, you can check this option to sort it before denormalizing. Click OK to create mappings from the source. Now if you look at the Denormalize object, you can see that it has 4 input groups and one output group, all having the same layout. And then there's this pivot and keys node, where you can see the SSN field we specified as our key. Let's map the SSN field from source to the SSN key in the Denormalize object. Now map the amount field from source to one field in each input group. Let's map it to city in the first input group, to county in the second input group, to state in the third input group, and to federal in the fourth input group. Now let's go ahead and look at the output. And you can see that it has created a new dataset with 5 columns compared to our source dataset that had only 2 columns. And all the text amounts have been grouped by each social security number and returned in a single record in different columns. The records have been denormalized sequentially because our source data did not have any column signifying the text type. So you can see that the values look kind of inconsistent or messed up in these columns, as in we have 100, then 10,021, then 1021, and then we have 200. In case your source dataset has a pivot value, you can use it as a driver field to create new groups in your dataset. Let's look at another example. So here I have another dataset that has one more field signifying the text type of each record. And if we look at it, you can see that for each record, it has returned the text type in a new field. As in for this SSN, it has 4 different types of texts: city, county, state, and federal. We can use this text type field as a pivot value to create driver fields using the second option in Denormalize properties. Let's go back to the properties of Denormalize and create fields for the layout. SSN, city, county, state, and federal. Click Next. And now you have to select groups based on values in the driver fields table below. Select the key from the drop-down list. Now you have to specify the driver field values. The driver field values are the different values in the pivot field. As in the text type column in my source data has city, county, state, and federal, so I'm going to use the same values as my driver values. Let's list them down in this grid. Our properties have been set, so we can now click OK. And now if you look at the Denormalize object, you can see all the nodes are expandable and have a layout. Let's start mapping. Map SSN from source to the SSN field in the pivot and keys group. Map the text type from source to the pivot value field. Now map the amount field from source to one driver field in each input group. Let's map it to city in the first input group, to county in the second input group, to state in the third input group, and to federal in the fourth input group. Now let's look at the output. And you can see that all the text records for city, county, state, and federal have been returned in different columns on the basis of pivot value and key field. We can now write this denormalized dataset to our target or use it in some transformation through this output port. So this concludes using the denormalized transformation in Centerprise. You can also visit our support site for more information on using Centerprise transformations. Thank you for watching this video.